Welcome to the next example, which reads, an ice skater with a mass of 50 kg is gliding across the ice at a speed of 8 meters per second. When her friend comes up from behind and gives her a push, causing her speed to increase to 12 meters per second, how much work did the friend do on the skater? We all know what skaters do. Maybe is during Olympics or just playing in winter, but we know that skaters slide along ice, and in this case we can presume that ice is too smooth, that the friction between the skater and ice is too small to be neglected. So the skater slides on ice, and if they slide, initially they have a speed of 8 meters per second, but when the friend pushes this skater, the speed goes to 12 meters per second. So here we notice that there is an increase in velocity, therefore there is an increase in kinetic energy. That's why the question requires us to get how much work is being done. We remember that the work which is being done in case there is a change in kinetic energy is equal to the change in kinetic energy. In this case, it will be kinetic energy final minus kinetic energy initial. This is work energy theorem. We go on. The work which is required now is going to be a half, because kinetic energy is a half mv squared. So the first kinetic energy is going to be a half m times v final squared minus, now the initial, this is the final kinetic energy, then the initial is going to be a half m v naught or v original squared. The work that is required will be a half times the mass of the skater, which is 50, multiplied by the final velocity, which is 12 squared, minus the initial kinetic energy, which is a half, times the mass, which is 50, times the initial velocity, which is 8 meters per second. If we feed everything here in our calculator, we are going to come up with an answer which is 2,000 joules. 2,000 joules, we can write this more clearly. And 2,000 joules is the same as 2 kilojoules, just as our answer is.